Hi everyone, this is the second part of a two-part video based on the setting out of a bastard hipped roof. In this example here, we will be focusing on a situation where the wall plate can only be moved vertically. The previous video focused on a situation where the wall plate could be moved horizontally. So we'll just move into it here now. So we'll just start by exploring the plan view to give us a deeper understanding of this hip roof. Then we will move on from that to show how the various rafters for this roof can be set out on an 8x4 sheet of plywood or a similar material. So here's an example of a plan view of your typical bastard hip roof. And as stated here, if the hip line is not 45 degrees on line, then that means the pitch at the end of the hip as opposed to the sides is not the same. So we just open back the surface there to have a quick look at the center lines underneath. So there you'll see the crown center line, hip center lines, common center line, and ridgeboard center line right here. So now we can see that the hip run line is the diagonal of the rectangle that's made up of the common and crown runs to fascia line. So here we have an equal soffit width all round off the wall, which is what typically you'll be aiming for. So I'm just illustrating that here with some animation. Of course, this means that the hip line itself will not be in line then with the corner of the wall plate if this is what you want. And of course, notice here that the corner of the wall plate, as stated, is not in line with the hip. But this is a higher level here, and this is at a lower level. If you want to maintain the same soffit width all around this building. And note the roof surface with the steepest pitch will have the highest wall plate. That's this wall plate here. The shortest run has the highest pitch. If it is not required to have an equal soffit width all around, then the distance between the outer edge of the wall plate can be increased, as animated just there. So just making the point here, if it's not required to have an equal soffit width all around, then the distance between the outer edge of the wall plate and wall can be increased, as I just animated there. So yeah, this of course means you can have the wall plate then at the same level, just that the soffit width will be wider. That's the only point I'm making there. But for the purpose of this exercise, we're going to keep the soffit the same all around. So here's a situation with the soffit same all around, and subtracting the hip tail run will leave the hip run from the wall plate as animated just there. Now that we've explored the plan view of this bastard hip roof, let's look at how to set out its rafters on a sheet of plywood or similar as mentioned earlier. Start by drawing the scale down rectangle formed by the common run and crown runs to fascia line. You will then add in the width and thickness of each member at full size or scale. The following is an example of how this should look set out on the end of a sheet of plywood. So here's the end of your sheet of plywood here now. So start by drawing that rectangle that I just mentioned, and the size of that rectangle is the common by the crown run to fascia. Draw that in and take up most of the end of the sheet with it. So you're looking at the 4-foot end of the sheet there, by the way, along the bottom. Then add in the fascia and rafters as illustrated here beyond those center lines, and you have the ridge crown and hips being added in there. And just note that from here to here is still full size, even with regards to the distance from here to here. So as well as that member being full size and that being full size, that distance from here to here is also full size. So that's just a point I want to make there. So you can measure your tail run of your hip, and you are getting the full size from there to there for the tail run of your hip. So just moving on from that then, now that we have the plan view set out on our setting out sheet, let's set out a different perspective of the same roof area, the vertical sectional view. Here you will see both perspectives, how they relate to each other, and how they will in turn apply to you the lanes, bevels, deductions for all of those rafters. And that's coming up here now. So here we are, and we're going to slide the sheet down now that we have the plan view drawn here first. And I broke the hip there, you see there, because that's not the full distance there just before we slid it down there. So here we have our blank sheet, and first thing we'll do, draw in a section of the fascia board on the edge of the sheet, and from the top corner there then we shall draw in the pitch line of our common rafter, and that should appear here now, animated any second. And yeah, here we go. There you go. Yeah, there's your common pitch animated in there. And after that then, from the same corner, we're going to animate in the crown pitch line. And this is basically, I call it the slate lat line or slate line or whatever. So you can offset in the whatever you need to deduct to allow for your slate and lats and slates, etc. And then draw in the rafter with offset from the pitch line to allow for the slating lats, as just stated there, and drawing the width of your rafter then as well. And of course drawing the wall plate in 1/3 into the common rafter. So you should have 2/3 left above. So here we have the crown rafter drawn in, but pay a close attention now how we get the bird's mouth onto the crown rafter. So we'll project the lower wall plate vertically onto the crown rafter as we just animated there now. So there you are. There's your bird's mouth in as well, of course. And now you can measure the difference between the wall plate levels. So if you measure from here to here, that is the difference between wall plate levels. Keep the upstands the same if you can. Now you might have to get a deeper common. Usually the lower pitch needs to be a deeper, slightly deeper rafter so you can maintain the same upstands. But I'm not too worried because you can have a slightly deeper upstand actually on the crown, as you'll see later on. So next we will have a closer look at the deductions that you will have to make at the rise point junction where the ridge, commons, crown and heap meet. So remember that whatever method you use to calculate the lengths of the rafters will only give you those lengths without factoring in the thickness of the roof members. The following will show you how to calculate those deductions from the initial plumb line based on the line diagram version of the roof. So here is your initial plumb line in the middle here. And that's the initial plumb line for the crowns, the commons, and for the hips. And but they each, after that, then they all have different deductions. And all those deductions are made on a horizontal plane, so they're square off the plumb line. Always remember that. So after this, of course, we'll just move down to the other part of the roof where there are deductions, and that will be where the bird's mouth is. So just finishing up here now. There was the last deduction for the hips. Now that we've explored the deductions, yeah, let's look at the bird's mouth as I just mentioned there. So again, there's an initial heel line down at the bird's mouth, but the fact that the hip has a thickness and not just a line will mean that this heel line will need to be adjusted, and this is illustrated here now. So there's your initial heel line when you measure down. So you'll have a line drawn down on the side of the hip, plumb line, and you'll have to offset that in by that distance into there. So just making that kind, keep the upstand distance here and here the same if you can. But you can actually afford to have a little bit higher here if you like. So next we shall determine our jack rafters for this roof to include the jack diminishes. So of course, jack diminishes the difference from the longest jack to the next longest jack. We shall start by measuring and marking the required jack center on the wall plate. So holding the measuring tape on the last common center line on the wall plate, keep marking the jack rafters or centers heading towards the hip until you get to the two shortest jacks, as you'll see animated here now. There's our two jacks, shortest jack and next shortest jack. And we've projected those white lines up so you can see it on the vertical section view and how they connect with your guide rafter. So you could have these points now marked on your common guide rafter. So, and there's your jack diminish from there to there for on the side of the roof that has the common rafters. This is the hipped end. So if we project those lines over, we will now get the jack diminishes for the hipped end of the roof. So there's your jacks coming away now on the common side of the roof, and these are the jacks just being animated away on the hipped end of the roof. And obviously they're left hand and right hand. You'll know from doing other hips. So next, for those of you that would like to plane on the dihedral angle on the hip rafter, we shall now go through the steps required to get this back and bevel onto this mastered hip rafter. This can also be done on your setting out sheet that we've already been using so far, as the hip, run line, etc. are already drawn in on that sheet, so we can take advantage of that fact right here now. So you already have, you'll have your hip line drawn from there to there. Put a square off it at 90 degrees, put on your rise for your roof, and just join on the diagonal back down. And that's the first step always to getting a dihedral angle. So we just zoom up there then, just so we get a better view of it. So because this wall plate is lower, I'm going to have to I'm drawing a line from here. So that line and this wall plate are on the same horizontal plane. So you draw that line at 90 degrees to the outside of the wall plate, and pick a point anywhere along the plan view of the hip, which is right there in our case, and shoot a line 90 degrees across it. And we need this junction then, and we will need this junction later on to create our dihedral angle for this particular roof. So the next step here then is from that junction that you picked earlier, drop a perpendicular line onto the true length line of your hip of that right angle triangle, the hypotenuse of that triangle, and another right angle triangle in other words. So that's you there. So it's the hypotenuse between the hip run and the hip rise, and you now swing. So if you had a compass, I suppose you could just put the point of the compass there and put the pencil on the compass there and swing that down onto here. Or you could just measure it. It's the same thing, So, and you need this point here then to form the angle. So you're going to be joining that point to this junction and that point then out to this junction here. And now in black, what you form there is your dihedral angle, or your back and bevel for the back of this bastard hip on this particular roof. Shaded in green there now. And I just showed a section through the hip there with the angle planed on it already. So if you were putting it onto a roof, you'd already planed the angle first before you'd mark the bird's mouth. And this is another way you can just put a banking angle, what I call. So that's the right side. That's the right distance to have up there on the common side of the bastard hip, and that's the right proper distance to have or angle on the in this case where the crown is. So now that you've completed this exercise, you should have enough information to get all that's listed there. Your lengths and bevels, and the difference in wall plate levels, and your jack diminishes, etc. And you should have a deeper understanding of what's involved. All the best. Hope that's of use. All right.